Hey there. Thanks for being there with AI Neurosky, where we learn with AI and master the future. 3D printing sounds revolutionary, doesn't it? It promises a future where we can make anything, anywhere. But beyond the hype, the real question is simple: when does 3D printing actually make economic sense? When is it cheaper, faster, or better than the way we make things now? Let's break it down, simply and honestly, to find the real answer. Every manufacturing decision, whether it's for a tiny screw or a massive airplane wing, comes down to three key factors: cost, speed, and volume. How much does it cost per part? How quickly can you make it? And how many do you need? The truth is, 3D printing doesn't win on all three of these at the same time. It's a champion, but only in very specific situations where its unique strengths shine. Let's start with where 3D printing can be surprisingly expensive. When you're talking about mass production, 3D printing really struggles to compete. Imagine you need 1,000,000 identical plastic bottle caps. Traditional methods like injection molding can stamp these out in seconds for pennies apiece. A 3D printer, on the other hand, would need to build each cap layer by layer, which could take hours for just one. The specialized materials can be costly, and the energy consumption and machine time for each individual part add up very quickly. So, when your goal is to produce a massive number of identical items, the old-school factory is still the undisputed king of low-cost production. For high-volume manufacturing, 3D printing is almost always the more expensive option. So, if it's not for mass production, where does 3D printing actually save you money? The economics flip entirely when the rules of the game change. 3D printing becomes incredibly cost-effective when your production volume is low. Think about making just 1, 10, or maybe 100 specialized items. It also excels when the parts themselves are incredibly complex or have intricate internal geometries that are difficult or impossible to make with traditional tools. Customization is another huge win. If every item needs to be slightly different, tailored for a specific person or purpose, 3D printing is the only logical choice. And here's a big one: it saves money when downtime is extremely expensive. Imagine a critical machine on a factory floor breaks down. Waiting weeks for a replacement part to be shipped could mean millions in lost revenue. Being able to 3D print that specific spare part in just a few hours completely changes the equation. In these scenarios, the speed and flexibility of printing on demand far outweigh the higher cost per part. Beyond that, there's a huge hidden cost advantage that many people overlook. 3D printing helps eliminate a lot of expenses that don't show up on a simple cost per part analysis. Think about it: you no longer need massive warehouses to store thousands of spare parts, just in case. The costs of inventory storage simply vanish. You also slash transportation and emergency shipping fees because you're not moving physical goods across continents, you're just sending a digital file. Most importantly, you avoid those crippling production stoppages while waiting for a part to arrive. When you factor in the money saved on logistics, storage, and operational continuity, the financial case for 3D printing becomes incredibly compelling, even if the printer and materials seem expensive upfront. This all leads to something called the break-even point. Picture a graph. For very low quantities, 3D printing is cheaper because you avoid the massive setup costs of traditional manufacturing. But as the quantity increases, the efficiency of mass production kicks in, and traditional methods become cheaper. That point where the two lines cross is your break-even point. Smart companies calculate this point with precision for every single part they might need. If the required volume is below that point, they print it locally, on demand. If they need more than that, they order it from a central mass production facility. This strategic decision-making is key to using both technologies effectively. And this is where artificial intelligence comes in to supercharge the economics. AI is making 3D printing viable in more and more scenarios. How? AI algorithms can automatically optimize a part's design, using complex, lightweight structures that use the absolute minimum amount of material while maintaining strength. This is called generative design, and it drastically cuts material waste and cost. AI can also analyze data to predict future demand for spare parts, telling you what to print and when, so you're always prepared but never wasteful. By optimizing every step of the process, from design to logistics, AI effectively pushes that break-even point further out. It expands the sweet spot where 3D printing is the smarter, cheaper option. So, what's the real economic model here? 3D printing isn't meant to be a wholesale replacement for factories. It's a powerful and strategic complement. It's just like having a specialized tool in your toolbox right next to the sledgehammer of mass production. When it's used correctly for the right jobs, prototyping, custom parts, complex designs, and emergency repairs, it lowers business risk, increases operational resilience, and ultimately saves money where it matters the most. It's about building a more flexible and intelligent supply chain for the future. Truly understanding technology means understanding its economics. If you want more realistic, no-hype insights into the future of industry and technology, make sure you subscribe to AI Neurosky. Together, we learn with AI and master the future. Thanks for watching.